Okay, so we've got grids. Hopefully everybody who's following along with me has those grids in there. Now I didn't do the extra credit, which you're going to have to do as part of your final assignment anyway, so I'm going to do it now. This wall right here, and I didn't get my slab in there, so let me put my floor slab in. And I want a 4-inch concrete slab. I'm going to go ahead and do the pick walls here. This was actually from assignment C that I didn't do last time. Flip those. Split. Oh. And as I think I told at least one or two of you, technically this slab wouldn't just run right through the wall like this, but I had you do it that way so that you could have practice with the split button. Okay, so now I'm going to put in that concrete masonry unit wall there. And to do that,
so we should or shouldn't have the board go through the wall?
You should just have it run on through. I mean, if you wanted to do it separately, that could be a little exercise that would be more accurate. But I just have the slab run all the way through for the sake of the assignment. So it's not truly accurate, and you really shouldn't do, as I say in this case, you should really do it the way it would really be built. Yeah. Okay, so I'm going to do the exterior brick. I'm going to duplicate the brick 12-inch wall type, and I'm going to call it CMU. So it puts a 2 after the new one. I'm going to rename that, and I'm going to call it CMU 7 5/8. And I'm going to double-click it and edit the structure and make that 7 5/8 thick. And the material is not brick, it is masonry dash concrete masonry units.
How do you know that? Because I just want to duplicate one, and I got stuck on the CMU part and the material.
Mm-hmm.
So I was going to do that, but I didn't know the material.
Okay. Then that's all right. I won't. If you did it and you didn't get the material right, it was extra credit anyway.
So I didn't even put that one in. I didn't put that one.
Okay. Okay. Yeah, I tend to be a little bit more sketchy on some of the extra credit stuff, but I'm also looking at the list, and if you have questions, I can always answer them.
So what was the material?
It's masonry dash concrete masonry units.
What properties did you change? I'm sorry, concrete.
You know what, I probably should have just skipped this step altogether because you don't have to have that there. I'm just going to move on because that was extra credit before. All we need are these 2 columns. I was just going to show that there's a wall there. Let me just go ahead and put that wall in here. And it's going to be on top. The only reason I put grid B in there is because it's kind of the center line of that wall, which is the one that I just made. And that's got to be from the basement level up to the first floor. I'm going to offset. So you don't have to do that part. I just want to throw it in there to show why we have a grid there. But the part we want to do is we want to put 2 columns at these grid intersections here. So we need to load a structural column. Yeah.
Whenever you add the floor slab and it asks you for would you like to join the geometry?
On the join one, you say yes. And what that does is if you cut a section, you'll see that the slab has been joined to the wall.
What was the wall height?
It's CMU 7 5/8. I think it was in one of the assignment D in the handout. I pointed to it.
What is the structure type?
1 layer of 7 5/8. Let me see if I can find it here. It might have been in assignment C, actually. No, here it is. There it's shown. Let's go back to assignment B. Yeah, I don't know that I actually called it out in the handout here anymore.
percent.
Oh, this is what it was in C. It was on the, like the page of C. It was on the top right.
Yeah, there it is. So if you zoom in on that, it says basic wall, partition CMU 7 5/8. And if you're not an architect and you didn't know that CMU stood for concrete masonry units, then that's just a bit of license that I didn't clarify for you. So
Is that on the side of D handout?
I'm looking at C.
Oh, it's back.
Yeah, it's back to C where I actually called it out. So that's a little misleading too. The best laid plans of mice and men on these handouts, sometimes I don't quite get everything as clear as I'd like. So, and again, you don't have to have that wall in there until we get to the end of the semester, but if you just want to kind of make a note for yourself, if you don't have time to put it in today, just remember it's shown and it's dimensioned at 14 5.5, which more or less centers it on this grid. From wall to wall, 14. Wait a minute. 14 5.5. Is that from the outside? No. Yeah. No, and it should be. Yeah, that's fine. Because really, you're going to have a bearing wall that's going to be sitting a little eccentrically on top of that CMU. I'm not going to count off. Yeah. We'll get a structural engineer to fix it. How's that? But I'm not going to count off if you have that dimension off a little bit there. What I do want to show is the columns. So let's see if we can move on with the columns. So if you go to the Structure tab, or if you go to the Home tab, notice column is on structure and column is on home. But notice there are two types of columns. There's a structural and an architectural column. And so regardless of which of the two menu tabs you're on, you have to make sure you pick the right one. And an architectural column can have more decorative shape to it. It can also be like a box that you put around in an office building when you have a gyp enclosure. And if you put an architectural column at the corner of the exterior walls, it does a funny thing. It'll actually engulf the gyp board and have it wrap that column. So if I put an architectural column here that overlapped my walls, and those walls were made up of, let's say, brick and metal stud and gyp board, Revit kind of makes the assumption that you want to take that gyp and wrap it around that square column if the architectural column is just this square thing. When we're dealing with structural columns, in this little house we don't have any architectural columns, but if you wanted to put an architectural column under your porch, for the heck of it, you can, and it would just be purely a, you might be able to find a column out there in the library or on the web somewhere that has a Doric column like that. But structural columns is what we want. Now you'll notice that on the type selector there's one family called pipe column, and it's got the Schedule 40 and Schedule 80, 4-inch diameter and 6-inch diameter. Now the Schedule 40 nomenclature has been left behind by the American Institute of Steel Construction, so the steel manual that those of us who are architects have this copy of the steel manual, if you still use that, that has all the shapes and sizes. They've changed the naming over the years. So I left this in there because it was an outdated name, because I wanted you to show what happens. We were talking earlier about how when you load a family, if that family has changed, it says, do you want to overwrite it? And it will also bring in additional types that you might not have. So we want some other pipe column types. The family name hasn't changed, but the type names have changed. And I called out in the handout that I want you to use one called Pipe 4XS, which is, their nomenclature now is extra strong. So there's pipe standard, pipe strong, and pipe extra strong in the steel manual these days. So we want to go to the Insert tab and say Load Family. And then we want to go out to that T drive. And I'm going to strangle the guy who was supposed to set these paths up for me. Figuratively, not. So we go to the 2012 Merrimack. No, actually, we don't have to go to Merrimack. Sorry. This is in the out-of-the-box library. So really, if you just hit Insert Load Family, this is all you need to look for, because this isn't one of my families. This is one that Revit gives you. So we go down to structural, and this is the out-of-the-box library right here. Actually, just back out of the command and let's just say load family. And I think on your machines it's actually going to look on the C drive because he didn't point it to the network. But it'll look in the out-of-the-box US Imperial, and you should see all these folder names. So if you got all those folder names, you're in an acceptable location, even though it's not the network. Each of your hard drives still has a copy of this whole specially loaded library that you get when you buy Revit. So if you have it installed on your laptop or on a machine at home, you'll have the same library. And one thing they get right in the families they give you is the structural stuff, because it's kind of hard to screw up steel shapes. They're pretty well defined, and it's very, precise, and there's only so much you can do with them. So if you go to structural, so don't go to columns, those are the architectural columns, go to structural. And then you go to columns, and then you go to steel. So there's the family pipe column. So even though we already have the family pipe column in our project, we don't have the types. Now, if you also are familiar with the steel manual, you'll know that there are page after page of shapes for each family. So there are probably 24 or more, you think, Corey, pipe column sections, and you might not want all those loaded in your project, because then when you look in the browser, you've got a whole long list to go through. So what Revit provides is something called a types table or a types catalog, so that when you load one of these families that has a lot of options to it, you only have to load the types that you need. So go ahead and highlight pipe column, and when you hit the open button, it's not going to load it yet. It's going to give you a list of all the possible sizes you might want. And luckily, they upgraded this so you can stretch that. It used to be this little window was just only so big, and you had to scroll up and down through like 3 lines at a time. So we look for pipe 4XS, which is a 4-inch diameter extra strong pipe. And if you're curious, you'll see that it's got the outside diameter, the inside diameter, the wall thickness, and it's got the weight per foot and the area. So all the properties that would normally be listed in the steel manual are in here. And we'll go ahead and load a couple extra ones too. I'm going to load the pipe 6XS just to kind of show if you're loading a couple, even though we don't need more than just the one. So now when you hit OK, Revit says you're trying to load a family pipe column which already exists in the project. What do you want to do? Now if I say cancel, I don't get those new types. So I have to pretend I'm overwriting it. Even though I know the pipe is going to be the same physical pipe, I'm wanting to add the additional types. Now if I...
Will it erase the existing types that don't match with the ones that you're...
No, and that's kind of what we were talking about earlier when Donald was asking what happens if you created types. Well, because those old types are already in my project, but they aren't in the library, it's going to leave those alone and just add the new ones to it. Now, if I had already loaded and made a 4XS and I'd made it the wrong diameter, then I would want to pick the second choice because I would want to override the parameters of the extra strong to match what they came out of in the table originally. But I don't have to do that if I don't even have the extra strong type in here. So I just picked the first one. And then if I scroll down in my families to structural columns, under pipe column, now I've got the 2 new ones I loaded, and I've got the 2 old ones. So if you want, you can just delete the old ones. You can right-click on the type and delete it. And one nice thing about getting the families in the browser, if you tried to delete one that was in use somewhere, it would warn you and say, you've already got 3 of those 4XS columns, do you really want to delete them? And then you can say, oh no, I didn't mean to do that. So now, you can either go to the home button and hit the column, structural column, and select it, or just like we've been doing with other things, you can just grab it off the browser and drag it out onto the screen. That kicks you into the structural column command, selecting that type. So now, remember how we found that you can align things with the align button, and if you want to lock them, like we did with the plumbing wall, you can lock things together. Well, when you place a column at a grid intersection, you don't have to lock it. Revit automatically says, okay, columns want to stay at grid intersections. So I'm going to go ahead and place 2 columns there. And now, even though there's not a lock, if I select the column, I don't see a little padlock or anything. But if I was to move grid A and change that to 6 feet here, notice how the column moved with the grid. And if I move this one to 9 feet, it moves in both directions with the two grids that it intersects. But if I select the column and I say I want to move that column 1 foot to the east, it will let me move the column away from the grid intersection, which, when you think about it, sometimes the structural engineer will say, well, I got to put a column that's off of that point for some reason. Maybe he's trying to avoid hitting something else. And so for that reason, Revit lets you do that. It's just a behavior that it's designed to do. So when you're placing the column, just make sure when you place it, I'm going to create somewhere here, make sure that both grids light up in blue before you click the intersection, and then you'll know that it's locked. It's locked in one direction to those two. So it'll move with them, but they won't move with it. So now, how do you determine the height of a column? Well, it's very similar to walls. So let's look at it in 3D here. And if you don't have your section box turned on, go ahead and turn it on. And let's pull the top down. Slice it off just below the first floor here. And there's my columns. Now we're not going to worry about how high they are at this point, but I just want to show you that they've got a base level, base offset, top level, and top offset, just like walls do. So from there, we actually want to set it so that the base is at the top of foundation and the top is at first floor. So I'm going to select both of those. Not top of foundation, top of footing, sorry. Base level should be TO footing. And the top should be, for now, 0 from the first floor. So that column kind of buried itself in the slab. And then when we come back from break, we'll put footings on the bottom of those columns. And we'll put in a beam. And that's going to be pretty much everything of the required part of E. And then I'll go into the optional extra credit part, which is stairs. So I'm going to go ahead and save this recording. Yeah, and you can set both offsets to 0. Structure.